I'm Shotade Olusegun. In today's particular live session, I'm going to tell you our formula of everything is being able to actually solve the Navier Stokes Millennium problem or Millennium problem. So now we're going to start with this interview, which was done by Curt, interviewing Professor Eva Miranda. So after that, I will give my own opinion and then, explain how formula of everything is able to actually solve the Navier-Stokes problem. So now, with no further ado, let's quickly dive into it. So,
extremely excited to be here and be speaking with you again. The last time we spoke, it went viral, so I'm super excited to have you on again because the audience just loves you. We're going to talk about hot topics. What you're presenting here, you're presenting for the first time in a manner that's introductory, so requires no background. The topics will include complexity, chaos theory, especially as contrasted with the standard chaos theory that the audience may already be acquainted with, Navier-Stokes, of course, what it means to go beyond what's computational, and how all of this is connected to geometry, to physics, to the ideas of Penrose and Terry Tao. Welcome.
Yes, thank you very much. I'm excited to be here again. I'm so happy to be here and looking forward to this new adventure and ready to disclose something new. Let's see if people like it. I'm very happy about all the followers, all the questions. I'm sorry I couldn't answer all the questions. I'll go and answer them little by little as I can.
Great.
And it's a great pleasure to be here with all of you now. Okay. I call this expect the unexpected. And what does it mean? Well, we all know David Hilbert, the famous mathematician, right? Who said, we must know, we will know. This was, let's say, his most famous sentence. And indeed, this was a little bit his idea that everything could be formalized mathematically in a very, very precise way. This idea of precision of mathematics, that is, of course, very important, and formalization, the idea of formalization of mathematics. And what's very interesting is that Hilbert was in Göttingen. I have been in Göttingen very recently, and it was a pleasure to be there and to walk around the streets and to see the plaques where all these great mathematicians were living, indeed. There was David Hilbert, there was John von Neumann, Robert Oppenheimer, who appeared in my last appearance in the Theories of Everything. Mm-hmm. And there was also Alonso Church, because Church and von Neumann went to visit Hilbert because they were excited about this formalization of mathematics. And of course, in their work, Hilbert's spaces were very, very important. But, well, I put here a rubber duck. We'll see what this rubber duck has to do with these big names. I want to tell you, indeed, today 3 different stories that have a common pattern, and the pattern is uncertainty versus the certainty that David Hilbert was looking inside mathematics, that every question had to have an answer in a way. And I chose 3 different main characters today. I chose Alan Turing. I chose to explain, as you said, the chaos, the theory of chaos, the classical theory of chaos. And this is a nice story that can explain with butterfly. Mm-hmm. And I want to explain also how it affects our last months. We heard so much about all these asteroids that could fall on us. So I want to explain how this is connected. And finally, I want to connect this to Navier-Stokes, to this unsolved problem in the list of unsolved problems in mathematics. And I will connect this to undecidable fluid paths. As you see here, I chose a little rubber duck, and the rubber duck is wants to be a little bit the new tag of logical chaos, in the same way the butterfly is the tag for the tag for classical chaos. So
Interesting.
let's see. How do I get to Alan Turing? I was talking about Alonso Church, right? And I was saying that Alonso Church was visiting David Hilbert to learn about this formalization of mathematics. And he was there in the period 1927 and 28. And the funny thing is that Church was indeed the PhD advisor of Alan Turing. So, Alan Turing is well known for cracking Enigma code. We've seen him in the films, The Imitation Game. And here we have the machine Enigma and the machine, the bomb, which was used to crack Enigma. So we could say that indeed Alan Turing and his team, it was all the team of Bletchley Park, managed to solve one problem that looked impossible to solve. However, there is a problem that Turing found impossible. He was able to crack the Enigma code with his team, but he found impossible the following problem, which is the halting problem. The halting problem looks a little bit strange. I'm going to try to explain it in easy words. Imagine that you have a process that is happening everywhere on the world. Now we could say that this process was just switching on your computer, right? Putting some input and getting some output. But at this moment in which I'm talking, there were computers that did not exist. So this could be an algorithm, something that is done repetitive. Now imagine you entering a labyrinth and trying to getting out of the labyrinth, right? So the input is the person entering a certain labyrinth, okay, a certain maze, and the process is getting out the maze, okay? And the question is the following. Is there a general recipe, an algorithm that tells us whether an arbitrary given process with some specific input data will stop, which means will reach the halting state, or continue to run forever? In the case of the labyrinth, is there a way to know if a certain person entering a labyrinth will be able to find out the way out in a certain amount of time or not? And or in a way, if we think of modern computers, okay, is there a supercomputer that can tell us if a given computer somewhere on the world will ever stop, which reach the halting state, or will continue to run forever? So this is the question that had been interesting a lot of people working in logics at the beginning of the 20th century. And it was a problem that was not solved. It was solved in 1936, and it was solved by Alan Turing, who proved that the halting problem is indeed undecidable. Okay, so Turing was the one in 1936, was the one to prove that the halting problem is undecidable. And you think, undecidable, that's a very strange word. It means that it cannot be decided. So this is a question that doesn't have a yes-no answer. This is pretty surprising, right? So this contradicts a little bit this strict way of thinking of mathematics as, you know, a door where you can knock and there's going to be an answer, right?
To be clear, for an undecidable problem, does the answer of yes or no exist, but we just don't have access to it? We can't know that it's going to be yes or no in a finite time?
We can know. We can know. It's like we have, you know, it's like we are with our mobile phone, right? And we are boarding an airplane, and the airplane doesn't have, we don't have access to the connection, right? So that's exactly the situation. We cannot know. There is no logical way to know the answer to this question.
Okay. But the answer does exist.
Well, we don't know if the answer... No, indeed, mathematically, we cannot say that the answer exists. We say that the answer is not... It's impossible to know. So, let's say, look, the question is very strange. The existence of supercomputer that tells you if a given computer on the world with some initial data will ever stop or not. Alan Turing proved that such a supercomputer couldn't exist, right? So we don't know the answer. We cannot know the answer. So this contradicts the saying of Hilbert, that indeed I think it's written on his tomb, that we must know, we will know. We must know, we cannot know. That's the truth. It's an uncomfortable truth that you cannot know. So in a way, it proves that mathematics also has its limits. So that's indeed a revolutionary idea, because indeed, in order to prove this statement, Alan Turing invented what is the theoretical model of a computer. Because in proving, how did he prove this? He proved this by contradiction, assume that such an algorithm exists, okay? And then you end up feeding the algorithm with the own machine you have created. The algorithm fills the algorithm, and then you get a contradiction. And by doing so, I'm not going to do the here, up or not, will this question have a yes, no answer? The story of modern computer began. So that.
And basically, I'm going to use this particular image that I have here to, drag my point home. So now, what Professor Eva Miranda was trying to say is that, problem of undecidability. That is it possible that we could have initial state of a particular, computer processing system that we either, stop or we go on forever. So now, further into the interview, Professor Eva Miranda was like trying to, solve, that problem by trying to integrate fluid, equation to, the discrete nature of, conventional computer information structure. So by trying to do that, I think she made mention of, using cosymplectic geometry to solve that, but the title of the problem which the Navier Stokes actually proposed isn't solved. You understand? So now the problem, the Navier Stokes problem says that if you have initial configuration, then as time goes on, if you have initial fluid configuration, and as time goes on, is it possible for one to have an emergent evolution of a continuous flow of information, or rather at a particular point get resorted to where you have this blow up, which is similar to singularity? You understand? That is what the whole idea, the whole problem of Navier Stokes proposed. You understand? So now in this particular video, I'm going to use the image that I have here to explain mechanics. It's a powerful formula, and so by applying the formula, there is a point where one can actually have a genuine contact with a missing piece of electron, which is positron, at higher dimension. And then by having this connectivity, there is this injection of that positron into the substrate dimension, which is the 2D in this case, and that will energize momentum into the black hole. Now by reiterating the application of formula of everything, then we'll be able to get to the core singularity suspended indefinitely. So it means that we have this blow up situation, but at the present phase, which is the phase that we can actually liken to event horizon. So where we have the first, detection of the positron, the actual position of the positron at higher dimension, that is where we have genuine contact. And there, we know that what we have there is having the alignment of accumulated mass worth in the nucleus of that singularity, which is the singularity of the trajectory of instancy. So now we will see everything in this image. So let me expand the image and then see how the whole thing can properly be solved. So now, when you look at this image, it is the time energy information system. The Turing tape, which is the theoretical, system of Turing computer, it has this tape where you could have, combination of zeros and one. And then that is what we have at the top, which is the digital information space structure. And this is rigid. It is rigid in the sense that, and by that virtue of being rigid, it means that it is discrete. Okay. Now, what I've discovered by formula of everything is that in the expansion of the universe, we have this, we have asymmetric nature, and then we have symmetric nature in the universe. And so we have this analog or continuous, flow of time being relativistically connected to discrete nature of energy. And the moment we have this, we're going to have that, tilt slice of time, as Einstein said it, that there is possibility to have, tilt effect of time, as we have object moving away from, the classical object into the past, and then we could have it into the future if we have that object approaching the real classical object. So now, I will explain how this analog information space structure can actually be integrated in our conventional information structure. So now, what we have under the tape is that analog information space structure, and that is flexible. Now, you see that whenever we have emergence, or what is usually being called collapse of wave, such that we have emergence of electron, or, in entanglement, we're going to have, positively charged particle and then negatively charged particle. So basically, it means that we have electron and positron. Now, the transmission of that information is instant, and it is instant because that point is where we have that transition from the substrate dimension, which is 2D in this case, to higher dimension, which is 3D. And so that has actually gone beyond the entire mechanics of the, or let me say, universe's mechanics of that substrate dimension. And so the transmission is instant. So basically, the solution for us to locate that positron at its exact position, we need to actually, travel at instant speed, which is the time's trajectory. We have to travel through time trajectory. So now, when you look at what we have here, we have emergence of 0 and 0. When you look at the equilateral triangle of that two bubbles, you can see that they are inversely related. Okay, the red bubble of 0, that is imaginary number, and then the black emergent bubble, that is real number. Now, when you look at the trajectory at the top, you can see that we have this curvature in this trajectory, and the trajectory can actually assume any number, and that is the analog part. So the mechanics of the trajectory will be analog, while the emergent what will be, discrete. So now we have it to be positive because it's actually traversing the positive region. And so now when you look at where we have the exact position of positron, we must have this trajectory beyond, the limit of the substrate dimension. And then we must have where energy is continuous. So the continuous flow of energy at quantum level to that continuous flow of time at classical level will give us that vertical trajectory. And so we're going to have that instant trajectory to connect to the higher dimension. And so we are going to have curvature of the mass accumulated momentum to that of energy curvature to have standing wave. And that standing wave could serve as, this fluid mechanism that Professor Eva Miranda was trying to talk about. So by having that standing wave curvature, then we're going to have this connection to the higher dimension to actually integrate the positron. And then by integrating the positron, then we're going to have momentum into the black hole. So now, by having this, we know that there is possibility for us to have analog integration into the discrete nature of information for us to arrive at solution. And then we can have two types of flipping mechanism. So now we have this flipped, which is, this is actually being flipped, contrary to this initial flipping mechanism that we have. So when we have this kind of flipping, we have two emergent zeros. And then when we have this kind of flipping, the one at the middle, we are going to have emergent of 1 and 1. So whenever you have emergent worth of real number, then we're going to have emergent worth of imaginary number. And then the connectivity between them is going to be relativity. And that kind of relativity that we have will actually be curved to give us this analog trajectory, which can actually assume any number. And so that is how we can actually have this hybrid information structure, where we have analog and digital. So the digital will be the final value that we get, and we can actually use that for computation. But the emergence of the discrete worth of that digital will be dependent on that continuous trajectory, either positive or negative, to give us either 1 or 0. So that is how we can actually have that computation. So I will further explain this by using, time energy wave model. Now, this whole thing actually leads to consciousness. And then, the moment we have that instant trajectory such that we get connected to the missing piece of electron, which is positron, then we're going to have feedback, which will be instant, and that will be transmitted to that classical mass world. And the sensation of conscious feeling that we're going to have will be as a result of that. So then it's going to be as a result of that. You understand? So now we now have emergent value based on relativity. So it is not that we map 1 and 0s onto electrical signals. So we have the emergent of that state based on relativity, and that is more genuine than what we currently have. So now, consciousness, to be informed, is the same thing as to be conscious. You understand? So now by using this kind of system, then imaginary number, we then know it to be an inverse determinant of what real number should be. You understand? In that analog information system. Then the inverse relationship of time, instancy to energy's infinity, is the flexible structure of space to adequately accommodate mass worth. So we are going to have that trajectory from 0 through to 1. So by using this hybrid information system, we're going to have optimization of space usage. So now, whatever value we have can adequately be accommodated by space, because we have a flexible space that can contract or, expand. So based on the mass worth of the value, the space can actually contract to adequately accommodate or expand to adequately accommodate. So not that we have blocks of space being assigned to mass worth that is not, that is not actually fitting the space. You understand? So now, then the dynamic mass worth to flexible space defines a system ideal for growing universe. So now, this particular system is going to be the ideal. But basically, I have a book on Amazon, and I call it The Invention of Time Technology. So this idea is all about time technology. So this time technology, we actually use 4 numbers. And the 4 numbers will be +0, -0, +1, -1. The 4 number, I call it quaternary. It's going to be quaternary instead of binary that we have in the conventional information system. So now, how do we model this? We can model this by having the +0 to be the value of what we have at, the singularity of Big Bang. So by having the charge to be positive, we're going to have the expansion as we have in the cosmological space to expand the universe. And then the trajectory is being attracted towards a -0. So we have the trajectory of classical mechanics to be towards -0, and that of the quantum mechanics to be towards -0. Now, where that we now have right inside the curvature, we have this equilateral triangle. And because when you have an action of, this mass convergence in time trajectory, you must also have reaction of that in energy trajectory. So we have this equilateral triangle, and then it is being suspended towards the 0, towards the -0, as you can see up right here. So the emergence of the mass worth that we have at the extreme end of that equilateral triangle, that gives us advanced charge, which is +1. So we now have +1, which is giving us arbitrary mass worth, both at the classical level where we have the black 0, and then at the quantum level we have red 0, and that is -1. So now we have that suspension, and by the virtue of that suspension, then it means that there is this time travel, and there is possibility for us to have the past, the present, and the future, because the trajectory is not being absorbed by that -0 to make it instant. And so because at that point where we have the convergence of arbitrary mass worths, energy is so low, and so we could have this free fall right from the top, right from the black circle, we have the free fall. Now that free fall will end where we have the red circle, but then the trajectory of that vertical line is so powerful that it could travel through that quantum suspension, and we call that to be spontaneous symmetry breaking. And by traveling beyond that convergence, where we have arbitrary quantum suspension, then we have moved into the nucleus of the black hole. And there we're going to have constantly accelerated momentum. By having that momentum to be energized, that will result to, shrinking the slices of that time peregrination to allow for curvature that can actually align with the curvature of energy. And by having that, we're going to have standing wave. Standing wave will now travel. The standing wave will be projected into the higher dimension, which is 3D in this case, to connect to the electron of the, quantum part of that higher dimension. And immediately we have that contact, then there will be this flipping mechanism that will flip that to positron for these 2D electrons to be instantiated. And that is what we actually call quantum entanglement. So now, by having that, because of that flipped mechanism, that positive charge of the positron will be injected into the system, and so we can have momentum into the black hole. Now we have another -0 in the singularity of the black hole, because the zero that actually attract, that is the -0, and the zero that actually eject, that is the +0. And we have -1, to be our positron, emergent positron. We have -1 to be emergent electron, while the +1 is the emergent positron. So basically, in this 2D, we have a balanced system at this event horizon, where we have emergence of positron and electron. But then the electron of the quantum mechanics is yet to be defined at this point for it to be connected to the electron of the higher dimension. And it's until when it gets connected to that we will now have the flipped mechanism that will define the real positron at quantum level, and then it inject that positron into that substrate dimension to energize momentum. So now, when we now move towards this -0, so you can see that we have suspension. We have suspension here, and it is known as inflationary suspension. And there is another suspension inside the black hole. I call it neutron star suspension. Now, right where we have the quantum arbitrary suspension to where we have the classical arbitrary suspension, where we have +1 and -1, we just have free fall there, which is the classical gravity. But right inside the nucleus, we have emergence of mass worth, which serves as resistance to that free fall, and that is the quantum gravity. Now, quantum gravity is so tiny to be efficient at classical level. So now quantum gravity is an inverse version of classical gravity. So that is that. So immediately after the suspension of that neutron star, we have convergence of mass worth, which is the clumps of mass worth. So basically, in that suspension, in that nucleus of black hole, we have real mass convergence. But in the suspension region of that Big Bang, we have convergence of energy. So we call it energy density and then mass density. So you can see that we have asymmetric nature all over the whole system. The mass worth of the Big Bang singularity is different from the mass worth of the black hole singularity. And that is why we could have the needed momentum constantly. If they were to be equal, there will be no momentum. And that is why we usually have this tilt effect of time peregrination, we have this tilt effect by having the discrete momentum of energy to be shorter to the continuous flow of time, for us to have this constant, momentum. So now, by that, we now know the whole system. Then I will now have to use another image to explain further, to explain how we can apply a formula of everything for us to know how it works, and how we are able to get, suspension that travels indefinitely, and then why we are able to have, this genuine contact. You understand? And then where we're able to have, this blow up singularity in the black hole, and then have this genuine contact, which we have in form of standing wave that gives us, that smooth flow for us to have reality at that event horizon. So now the time technology uses quaternary, which is using +0, +1, -0, -1. Digital computer uses binary. So that is that. Now, I'm going to use this second image to drive my point home. Okay, so now this second image is all about complex system of the universe. And when you look at the equation we have here, this is having e to the I theta, which is the complex wave. So right inside the wave, we have cosine theta, which is the real wave, plus I sine theta, which is imaginary wave. Now, when we'll now extract the two waves such that we have this wave pattern, then we can see how they travel in time. Imaginary wave is the red wave pattern, while the real wave is the black wave pattern. Now, I want you to look towards the right where we have this point, the black wave pattern. At the central point, central line, we have this dot. When you look at that, you see that when the real wave reaches the central point where the energy will be so low, then we have imaginary wave to be at the peak of its own energy. So definitely we can say that imaginary wave serves as, energy reservoir for real energy wave. And that is why we usually have this flipping mechanism of the complex system. So we have this flipping mechanism between imaginary number to real number. So when you have I, the solution of I is square root of -1. So we shouldn't have that, and that is why they call it imaginary number. When you solve it further such that you have I to the power of 2, then you're going to have -1, which is real number. So when you solve it further such that you have I raised to power 3, then you are going to have, negative I. You understand? You can see that flipping. And when you now solve it further that you have I raised to power 4, what you have is going to be 1, which is real number. So we usually have this flipping from imaginary number to real number. And that is why the emergence of the what that we're going to compute will be that of the imaginary number and real number, just as I showed you in that particular image. So now, we usually have this flipping mechanism, and by what we usually have been flipped is equilateral triangle. And so we often have this transition from 2D to the 3D. So when it comes to complex system, there are 4 things to consider. We should consider number 1, 2D to 3D transition. Number 2, quantum entanglement. Number 3, flipping mechanism. Number 4, complex system integration. That is the point where we have positron being injected into the substrate to energize momentum into the black hole. So now when we now look at the O complex system as the reality we should have, then we're going to have this stacking of the stacking of the inversely related equilateral triangles at the vertical trajectory of event horizon. And by applying formula of everything, the solution that we have is quasar-like signal, and that is formed right at the core of black hole singularity. Now let's see how we can apply formula of everything. Application of formula of everything, that is what we have down here. So formula of everything, you can as well call it FoE, and that is dt dm equal to capital Um plus 4m. That is the formula. Now when we substitute this value of electron, which is 9.109 times 10 raised to power minus 31 kilogram, into that formula, we're going to get what we have under the first result phase, and that will give us this 2,277,250,000 kilogram. That is going to serve as the classical mass value. Now, for us to now reconfirm that quantum value, then we need to substitute the classical mass what into the formula again. Don't forget, I told you earlier that formula of everything feeds back on itself. So now, by putting that classical mass worth, what we're going to get is going to be this 5.7 times 10 raised to power 48. Now, this is the point where we have that classical suspension, where we have this diagonal linear trajectory. You understand? So we're going to have free fall. That means we're going to have spontaneous annihilation of that suspended zeros. And for that purpose, we need to extend this value in standard form. And when we do that, we're going to have what we have below here. And we can see that the value of strong conveying force is being suspended. Strong conveying force now suspend the weak conveying force at 30 seconds. Now see what we have here. We have the value of 9,109 being suspended right there. So we have a couple of zeros after. So this suspension shows that we have that suspension right inside the curvature of time. So because we do not have it to be negative value, everything is at classical level. So how can we now get connected to the quantum level? It is by manually annihilating the suspended zeros. To do that, then we will have to now divide the 9,109 by 10 raised to power 32, which is the position where that weak conveying force is being suspended. And then when we do that, if we now expand the fraction, we're going to have 9.109 times 1 all over 10 raised to power minus 32. So if we now finally solve that, we're going to have 9.109 times 10 raised to power minus 32 kilogram. Now see that what we have is not actually reconfirming the actual mass worth of electron. So we have what is smaller to actual value of electron. And the reason is for the fact that that vertical trajectory, which is the instant trajectory of time, you can only apply it one time. Though you can travel forward and you can travel back, because at quantum level we know that particles do travel back in time. But at classical level, we cannot travel back in time. So you can travel back, you can travel forward, but it has to be once. You get real position of the particle at quantum level at one time when you travel through that trajectory. So what we now have here is showing us that the trajectory has shifted into the black hole, and so we now have this effect of decay on that mass worth, and so it is smaller to the initial electron's mass worth. So now let's now use this mass worth, the quantum mass worth, in our formula and see what we get. Now when we substitute that in the place of the two m's, in the place of the two m's, now don't forget that we have 4m, so we are putting that value in the place of the m in front of 4 and the m in front of capital U. Now, when you look at this formula of everything, you can see that the T, the M represent the curvature of time to curvature of energy. And then we have a nested linear solution right inside it by having capital UM plus 4M. So now, after substituting that value, our result is now 277 billion. Not billion this time. We have it to be 277,725,000 kilograms. So you can see we have dot here, we have some zeros, and we have 3 kilograms. That value that we have after the dot is insignificant. We can get rid of that. But now we can see that the tiny decay effect of -1 at quantum level has resulted to huge decaying at classical level, which is almost about 2 billion. And that we can call butterfly effect. So, but in this case, we have real, result, because we are using formula of everything. And so now, when we now substitute this value in our formula to see what we get next, then we see that what we have as value is 6.9 times 10 raised to power 47. So we are at classical level this time. So now we need to expand in standard form like we did the other time. So we have it being suspended at 31st position. 31st position is the power of electron. So we have that being shifted back. Can you see that swing forth and back right there? But then the base worth of electron is being decayed to 11109. So now you can see that is being shifted forward. That is why I said we have this quasar-like signal, which is in form of swing forth and back. So now, this value, we need to manually annihilate suspended zeros. And what do we get? So we have the 11109 divided by 10